If we come back to our player character here, and if I just scroll down, notice we've got this list of weapons. So this property represents the weapons that the player character currently has in their possession. If we scroll down to the constructor, we're calling this create starting weapons method, and if I click on that and hit F12, we can go to the definition, and what we're doing here is setting each new player character to have a default set of weapons. So each new player character by default has a longbow, shortbow, and short sword. Let's see how we can use xunit.net to write asserts against this collection of weapons. So we'll head back to our test class, and we'll start off by writing a test to check that the list of weapons contains a specific weapon. In this case, we're using the assert.contains method. The first parameter is the element that we're looking for, and the second parameter is the collection. So here we're saying the weapons collection should contain a longbow. Let's build this, and head to Test Explorer, and if we scroll down, we can see our new test. Let's run that, and the test passes. If we head back to our player character, and we just comment out the longbow, if we run the test now, the test should fail, because the collection no longer contains that element. And we can see the failure message here, telling us that the longbow was not found in the list of values, shortbow and short sword. So this is quite a helpful error message. Let's just fix that up. We'll uncomment this line, and now once again the test should pass. There's a complementary does not contain method. So let's add a new test here, calling the assert.doesNotContain method, and we're checking here that the list of weapons doesn't contain a Staff of Wonder. Let's build this to make sure the test shows up in Test Explorer, and we'll run this new test, and the test passes. If we were to go and add a Staff of Wonder, this test would now fail, and we can see the error message that we found a Staff of Wonder when we should not have. Let's just fix this up, and once again the test will pass. There's some more advanced uses of the contains method where we can specify a predicate to match an element. So let's write a new test to check that the list of weapons has at least one kind of sword. So once we've created our player character instance, once again we're going to call the assert.contains method, but this time we're going to use an overload that takes as a first parameter the collection and the second parameter a predicate. So for the first parameter, this will be the list of weapons, and as the second parameter, we need to specify a predicate that's going to verify that the collection contains an object that matches the predicate. So here we're just going to use a lambda expression. We're going to say that weapon goes to weapon contains sword. So weapon here represents the string containing the description of the weapon, and what we're doing here in the predicate, we're using the contains method of the string object to check that the total weapon description contains the substring sword. Let's build this, and head to Test Explorer. We'll run the new test, and the test passes. If we were to go and change the list of default weapons and comment out the only sword here, the short sword, when we run the test now, the test is going to fail because there are no elements in the collection that match our predicate. And we'll just check this still passes, which it does. We can also assert that the total collection is as expected. Once again here, we're using the assert.equal method. The first parameter here is the expected collection, and the second parameter, the actual collection. Let's build this, and we'll go and run this new test, and the test passes. If we were to go and make a typo here, so I'm just going to add an extra x, and run the test again, we can see that the test fails because the elements in the expected and actual collections are different. Let's just fix that up. If we want to make an assert against each item in the collection, we could do this in a for loop, for example. Alternatively, we could call the assert.all method. The assert.all method is going to loop through all of the weapons here, and it's going to execute the assert.false method against every item in the collection. So in this case, we're checking that no weapon in the collection is null or is just set to white space. Let's build this and run the new test. And the test passes. If we head back to our player character, and we'll add an empty weapon string here. When we run the test now, the test will fail, because not every weapon in the collection satisfies this assert.false. Let's fix this up, and run the test again. And now the test passes. If we have inheritance hierarchies in our application, it may be useful to write asserts to check that an object is of a specified type. If we have a look at this enemy factory class here, this class has this create method that essentially creates either a boss enemy or a normal enemy. So if the isBoss parameter is set to true, we'll get a new boss enemy created, and if this is set to false, we'll get a new normal enemy created. We have this enemy base class here, and we also have a normal enemy that inherits from this base class. We also have a boss enemy, which also inherits from this base enemy class. So let's see how we can go and write some tests to check that this create method is returning the correct type of enemy. We'll create a new test class, and we'll call this test class enemy factory should. We'll add the using xunit directive. We'll make the class public, and now we can add our first test. So let's start off by writing a test that's going to check that we get a normal enemy back by default. We'll create our system under test, in this case the enemy factory instance. We'll call the enemy factory's create method and pass a name for our enemy, in this case zombie. And now we want to check that the object returned by this create method is of type normal enemy. To do this, we can use the assert.isType method and supply the generic type, in our case normal enemy, that we expect the type to be. We're going to check the type of the enemy object that was returned from the create method. Let's build this, and we'll head to Test Explorer, and we'll run our new test, this time in the enemy factory grouping. Let's run that, and the test passes. There's a complementary isNotType method, so let's add a new test to demonstrate this. This time we're calling isNotType and specifying datetime here as the type. So we just need to go and add a using system directive. And now we're saying that the type returned from the create method should not be of type datetime. We'll build this and we'll head to Test Explorer, run the new test, and this test should pass because the type is not a datetime. Let's write a new test to check that if we specify true as the parameter here to the create method, that we do in fact get a boss enemy type returned. So once again here we're using isType and we're specifying boss enemy as the type we expect. Let's go and run this new test. And the test passes as expected. If we were to change this, for example, to normal enemy and run the test again, we can see the test fails because we expected a normal enemy, but we actually got a boss enemy. We'll just fix this up and check the test still passes, which it does. When we're using the isType method, if the assert succeeds, we can get back the object of the specified type. So in this test, we're once again calling the assert.isType method, but we're actually making use of the return value of the isType method. If the type of enemy is not a boss enemy, the isType assert will fail and the test will fail. But if the type of enemy is a boss enemy, then we'll get this result returned into this boss variable, and then we can make additional asserts on the boss enemy type. So for example here, we're just checking the boss name. Let's go and run our new test. And the test passes. The assert.isType method checks for type equality in a strict fashion. So for example, if the returned result is a derived type, assert.isType will still fail. Let's create a new test here to demonstrate this. Once again, we'll create the enemy factory and then call the create method, specifying that we want a boss enemy returned. If we use the isType method and specify enemy as the generic type, this test is going to fail. We're going to get a boss enemy returned, and even though boss enemy inherits from enemy, isType operates in a strict fashion. If we run this test, we'll see this fail. We can see that we expected an enemy, but we got a boss enemy. If we wanted this test to pass because a boss enemy derives from enemy, rather than using the strict isType assert, we can instead use the assert isAssignable from method. Once again, we're specifying the generic type here as enemy, but unlike the assert.isType method, isAssignable from will take into account any inheritance. If we run this test now, the test will pass, because we're no longer using the stricter isType method.